an apartment. Down handle is still on this side.
This is Delta Launch Control at T-minus 15 minutes and holding. We have approximately 8 minutes remaining in this planned 20-minute built-in hold. We're going to look now at some animation of the flight profile of the Delta II and some of the ascent events that it will be going through as it lifts off away from the pad tonight. This is essentially as we see the Delta II on the pad at this moment. We have ignition and liftoff. The vehicle actually will be going through the sound barrier 33 seconds after liftoff. Maximum dynamic pressure 48 seconds after liftoff. The fairing will be separating at about 4 minutes and 37 seconds. The second stage will be burning until it goes into a coast phase that will last about 43 minutes. Then there will be a restart of the second stage for a very brief burn, followed by spinning up the third stage and the spacecraft in preparation for spacecraft separation. And then we have SEP occurring about 5 seconds later. And then the spacecraft will despin from a rate of about 55 RPMs down to 0 after it separates from the third stage. At T-minus 15 minutes and holding, this is Delta Launch Control.
L minus 30 minutes.
Following personnel report ready to proceed with countdown. ACC.
ACC is ready.
ATC 2.
Ready.
ATC 3.
Ready.
EEA.
Ready.
ESOS.
Ready.
FMA.
Ready.
FSC.
Ready.
GE.
Ready.
HYE.
Ready.
MEA.
Ready.
MIFCO.
Ready.
OSM.
Ready.
PEA.
Ready.
Prop 1.
Ready.
Prop 2.
Ready.
RC.
Ready.
NSC.
Ready.
RCO.
Ready.
SSC.
Ready.
SSB.
Ready.
SYS.
Ready.
TM1.
Ready.
TM2.
Ready.
VE.
Ready.
VP.
Ready.
VSE. I think you may be on another.
LCDR, MCE, and VSC are working an anomaly, or
Roger that.
discussing a question.
All right. And are you ready at this time, Launch Director? Or do you want to? Launch Director, LCDR. This is MCE on 1.
VSE on 1.
Yes, sir. Gentlemen, just looking for your readiness to proceed with countdown.
MCE is ready. VSE is ready.
And Launch Director,
LD's ready.
copy that.
L minus 26 minutes.
CLCDR, resume the count at the end of the built-in hold.
Roger. Stand by for release of the hold.
Like unlock sync then.
This is Delta Launch Control, T-minus 15 minutes and holding. We have approximately 20 seconds remaining in this planned built-in hold. That will take us down to our next hold at T-minus 4 minutes, which will be a 10-minute built-in hold. Coming out of the hold now in 3, 2, 1, T-minus 15 minutes and counting. This is Delta Launch Control.
SSB, report second stage oxidizer tank pressure.
178.2.
178.2.
SSB, report second stage fuel tank pressure.
139.5.
139.5.
SSP, report second stage helium and N2 pressurizations are normal.
Normal.
SSP, verify second stage helium regulator lockup pressures a go.
Go.
SSP, verify second stage nitrogen regulator lockup pressures a go.
Go.
HYE, verify first and second stage hydraulics are go.
Go.
DST, verify RF link checks are complete.
Complete.
LCDR, countdown limit conditions T-minus 15 minutes to on.
On.
GE, perform T-minus 4 and T-minus 60 limit checks on the backup TFE. Report complete on channel 5.
Roger.
This is Delta Launch Control at T-minus 12 minutes, 39 seconds and counting. The Kepler telescope is built for NASA by the Ball Aerospace and Technologies Corporation. It consists of the spacecraft bus and a single instrument called a photometer. The spacecraft weighs 2,320 pounds, comprised of 1,240 pounds for the spacecraft bus and the support systems, and 1,044 pounds for the photometer, and 26 pounds of hydrazine propellant, which is also on board. The telescope is 15.3 feet high and 9 feet in diameter. Its 4 solar panels produce 1,100 watts with X-band and Ka-band communications antennas. The life of the telescope is projected to be between 3.5 and 6 years.
SSE, report third stage system external current.
At T-minus 11 minutes, 35 seconds and counting, this is Delta Launch Control.
Transmitter external power to on.
On.
And the current?
1.2.
1.2.
SSE, report third stage TM baseplate temp.
7-1.
7.1.
TM2, obtain third stage TM data trend.
Roger.
T-minus 10 minutes.
MCE, report load relief checksum number. Today's load relief checksum number is 16 Foxtrot 7.
16 Foxtrot 7.
FMA, QAM. Perform the load relief wind data loading per task 3 Baker. Use channel 6. Report complete on channel 5.
Roger. Checksum 16 Foxtrot 7. And send work.
ACC, report fairing inlet temp set point.
70.0.
73.0.
RCO, report vehicle beacon go on external power.
Vehicle beacon is go on external power.
Prop 1, verify engine regulator is a go.
Go.
Prop 1, report engine section temp.
64 degrees.
64.
Prop 1, report lube line temp.
60 degrees.
60.
Prop 1, verify booster helium and nitrogen pressures within limits prior to end of built-in hole.
Roger.
And Prop 1, established vehicle fuel tank vent is closed.
Established closed.
Prop 1, vehicle fuel tank press open, pressurized tank to 24 to 30 psig.
Pressurizing.
T-minus 8 minutes.
Prop 2, PSD purge press open.
Open.
Prop 2, verify locks umbilical purge is closed.
Closed.
PEA, verify FABU and engine heaters are go.
Go.
PEA, verify overflow line temp rise is less than 12 degrees.
Verified.
Delta 1 says Cape
QAM,
on that.
LCDR.
Go.
Would you give us a read back on step 3 on page 98,
Delta Wind,
please?
go ahead.
HR3 terminated
Step
at
three was
52.4
70
K
decimal
feet
zero.
with 2 edits, with their surface to 200 feet and 24.1 to 24.3 K feet. LR4 Alpha terminated at 53.5 K feet with a surface to 200 foot for the only edit.
Delta Winds, copy that.
Cape Wind's out.
Delta Winds out.
Perform third stage internal transfer.
Active. Scripts complete.
Prop 1, report locks relief plenum pressure.
8.4.
8.4.
Prop 1, report locks relief plenum temperature.
61 degrees.
61.
Prop 2, verify locks, VE locks bleeds and lock start tank are venting.
Verified.
Prop 2, top locks to 100% and verify 100% lock float switch operation one time.
Roger.
Prop 2, allow locks to boil off, maintain a low locks level between 99 and 100%. Report when complete.
Roger. T-minus 6 minutes.
ATC 2, pressurized facility water tanks.
Pressurizing.
TM2, report internal bat mon volts.
32.1,
32.1.
TM2, report TM bat mon volts.
31.7,
31.7.
TM2, obtain third stage internal data trend.
Roger.
We'll verify area weather conditions, go for launch.
Weather is go.
T-minus 5 minutes.
SSC, perform third stage external transfer using the command sequencer.
Scripts active. Script complete.
OSM, launch enable closed.
Closed.
Prop 1, launch enable on.
On.
SSP, launch enable on.
On.
ATC 3, launch enable on.
On.
SYS, verify no record on change list are activated.
Verified.
Timer at T-minus 4. Verify the sequencer is holding.
Roger.
This is Delta Launch Control, T-minus 4 minutes, 4 seconds, going into the hold in 2, 1, T-minus 4 minutes, and holding for 10 minutes. Delta II Mission Director Rich Murphy has just polled his team for their readiness to continue.
Restart the sequencer.
And at this time, we are go into our terminal countdown sequence, which will be after 10 minutes in this hold. We will be at T-minus 4 minutes and counting down to our T0 time at 10:49:57, 3 seconds short of 10:50 p.m.
Prop 2, cycle locks, fill and drain, valve closed, then open 3 times, verify proper response, and leave open, report when complete.
Roger.
Roger. That's complete.
Prop 2, cancel display and deactivate record on change list for engine start.
ATC 3, report the amp hours remaining for the following. CRD 1 bat,
1.41.
1.41.
CRD 2 bat,
1.42.
1.42.
This is the NLM on the NLMnet with a ready to proceed with terminal count and release of the hold at T-minus 4 minutes. NASA CE.
NASA CE go.
NASA MEM.
NASA MEM go.
SMA.
SMAs go.
SMD.
SMDs go.
NAM.
NASA advisor team's ready.
Copy that. NASA team's ready to release the hold at T-minus 4 minutes.
This is Delta Launch Control at T-minus 4 minutes and holding. As we've heard, we are ready to pick up the countdown at T-minus 4 for the terminal countdown sequence. And we'll look now at some tape taken earlier this afternoon of the rollback of the mobile service tower from around the Delta II in preparation for our launch tonight. This is at launch pad 17B, where we see the Delta II with Kepler atop enclosed in the fairing. Numerous personnel are required to retract the access platforms from around the Delta II, as we see underway here. This mobile service tower provides the primary access to work on the Delta II while it's on the pad, as well as providing weather protection, particularly for the area around the fairing. The first motion for the mobile service tower came at 2:15 this afternoon, when it began its slight first motion back. It stops briefly for some checks before proceeding into higher speed and moving all the way back to its parked position about 1,000 feet away. The entire operation took about 40 minutes to perform. And at 2:55, the tower rollback was complete.
OSM, SSC, Talker, FSC, and ATC-3. All personnel, if a condition that exceeds the launch constraint is observed during the
launch conductor has performed his final poll of his team, and we are ready to pick up the countdown at T-minus 4 minutes.
No expected or allowable alarms after T-minus 60
At
seconds.
T-minus 4 minutes and holding, this is Delta Launch Control.
Channel 1 until after launch, and then end of a hold after T-minus 4 minutes. Recycle steps will begin in Appendix K. Appendix K is the yellow pages. To prevent the possibility of a hang fire, personnel with launch enable switches are instructed not to switch launch enable to off or open after T-minus 4 seconds. In case of engine cutoff or no vehicle liftoff by T+5 seconds, recycle and safing will be performed per Appendix L. Appendix L is the red pages. SSC calibrate third stage telemetry 2 minutes prior to picking up the count.
Roger.
Now minus 6 minutes.
NSC, request spacecraft, configure for launch.
Roger.
This is Delta Launch Control, T-minus 4 minutes and holding. 1 minute remaining in this built-in hold.
Minus 5 minutes.
TLCDR, proceed with terminal count at the end of the built-in hold.
And we have permission to proceed with the terminal count.
125 plus or minus 25 PSIG.
Verified.
The
word latch
launch team tonight is
LCDR.
recognizing engineer Stan Rodney, who passed away recently. He's an engineer for Pacific Scientific.
Stand by for release of the hold.
His name is actually on the umbilical tower tonight in recognition of his service to the team, particularly in solving an issue associated with the third stage timer. Standing by now for release of the hold, coming up in about 20 seconds. Once we get to 2.5 seconds, the button will be pushed and will be on automatic sequence. Picking up in 2, 1, T-minus 4 minutes and counting.
SSC, perform vehicle internal transfer.
Active. TM internal, control internal, boosters internal. CRD's internal, beacon internal, TM internal, control internal. Complete.
SSC, perform vehicle arm.
Active. SNA 1 and 2 arm, boosters armed. Forward 1 and 2 arm. Scripts complete.
SSC, perform third stage internal transfer.
Active. Third stage internal. Scripts complete.
T-minus 3 minutes.
OSM, third stage SNA arm permit to close.
Closed.
SSC, third stage SNA arm.
Armed.
Prop 1, vehicle fuel tank press open.
Open.
Fuel umbilical purge to open.
Open.
FSC, bat 1 heater control
Exit.
FSC, bat 2 heater control exit.
Exit.
NSC, report spacecraft is go.
Kepler spacecraft is go.
Once we have liftoff, we'll be hearing our telemetry manager, Steve Agate, in the telemetry lab here in Hangar AE at the Mission Director Center, calling our flight events through spacecraft separation.
SSC, FTS, bat 1 and 2 heater controls, heaters off. Prop 1, pressurized first stage locks tank to relief.
Pressurized. 10 seconds.
Prop 2, top first stage locks to 100% levels.
Top it at 100%.
Seconds.
SSC, hydraulic external power to on.
External.
Launch. Range, go for launch. TLCDR, you go for launch.
Roger.
70 seconds.
SSC, hydraulics internal.
Internal.
T-minus 1 minute and counting.
LCDR countdown limit conditions, T-minus 60 seconds to on.
On.
100%.
Seconds.
CLCDR 17B, launch enabled to flight.
Flight.
ATC 3, main power disabled on.
On.
35 seconds.
Hydraulics go.
30 seconds.
T-minus 30 seconds and counting.
22 seconds.
We have
20
a
seconds.
green board here in the Mission Director Center.
15
T-minus
seconds.
15 seconds.
13 seconds.
Green board.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Engine start. 1, 0. And liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Vernier engine chamber pressures are building. Groundlet solid motors are building in chamber pressure. Increasing at this time. Pressure's looking good. 1 second into the flight. Recovering from the initial launch transients. Passing 34 seconds. Mach 1. Vehicle's now going supersonic. Motor chamber pressure is beginning to trail off as we're passing 45 seconds. Engine chamber pressure, good steady state value. Symmetrical burn on the groundlet solids. Coming up 55 seconds.
And we have a sequencer on channel 1. Sequencer.
Standing by for burnout.
Give me a liftoff time. 03.
Burning out of the solids.
49.
For separation.
7.465.
See separation.
7.465.
And we have ignition of the airlit solid motors. Airlit solid motors building in chamber pressure. 1 minute, 22 seconds into the flight. Delta II vehicle now only weighs about 1/2 of what it did at launch a minute and 28 seconds ago, losing propellant at the rate of about 2,200 pounds per second. 1 minute, 35 seconds. Altitude now 15.4 nautical miles. Downrange distance 35.6 nautical miles. Velocity 3,393 miles per hour. 1 minute, 48 seconds. Airlit motor chamber pressure is beginning to drop. Only about 10 seconds more before we burn out those airlit solids. Anyway, for SEP, and we have separation. Airlets have separated. Seconds into the flight. Altitude now 31.3 nautical miles. Downrange distance 79.5 nautical miles. Velocity 5,398 miles per hour. 2 minutes, 30 seconds. Main engine chamber pressure is still very steady. Vernier engine chamber pressure is still very steady, right in the expected range. Engine transients are settling down now as we're approaching the 3-minute mark. Mark, 3 minutes into the flight. Altitude now 43.5 nautical miles. Downrange distance 134.6 nautical miles. Velocity 6,980 miles per hour. Very minimal steering now on the main engine pitch and yaw and on the verniers. Now passing 3 minutes and 27 seconds into the flight, less than 1 minute until main engine cutoff. Altitude now 53 nautical miles. Downrange distance 197.5 nautical miles. Velocity 8,962 miles per hour. 2 minutes, 50 seconds into the flight. Good main engine and vernier engine steering. As we're passing 4 minutes, 27 seconds now until main engine cutoff. Altitude now passing 62 nautical miles. About 10 seconds until main engine cutoff. Chamber pressure beginning to decrease. We have MECO, main engine is cut off. Standing by for 1-2 SEP. And we have ignition on the second stage. Second stage chamber pressure is beginning to build. Jettison time on time. Good steady state engine chamber pressure on the second stage. Looking at second stage engine steering. They're recovering from the initial transients, looking good. Five minutes, 30 seconds into the flight. About 1 minute into this second stage burn. Second stage burn is to last about 5 minutes and 20 seconds or so we have about 4 minutes to go. Chamber pressure is very steady in the second stage. Pitch and yaw control in the second stage, very good. Passing 6 minutes, 6 seconds into the flight. Altitude now 89.8 nautical miles. Downrange distance 641 nautical miles. Velocity 13,834 miles per hour. Looking at our comparison of our expected times and our predicted times and our actual times of major mission events are all within a second of their expected times. Passing 6 minutes, 47 seconds into the flight. Altitude now 95.4 nautical miles. Downrange distance 778 nautical miles. Velocity 14,271 miles per hour. Passing 7 minutes. Chamber pressure is exactly where we want it to be in the second stage. Very good chamber pressure, holding rock solid.
We're now on data from Antigua Island.
Pitch and yaw control in the second stage continuing to look good as we're approaching 7 minutes, 30 seconds. 7 minutes, 40 seconds into the flight. Altitude now 99.9 nautical miles. Downrange distance 955 nautical miles. Velocity 14,899 miles per hour. Now passing 8 minutes into the flight. About 2 minutes until SECO. That'll be the completion of the first burn of the evening of the second stage. Passing 8 minutes, 30 seconds into the flight. Altitude 102.2 nautical miles. Downrange distance 1,131 nautical miles. Velocity now at 15,567 miles per hour. Looking at our second stage chamber pressure, again, continuing to look very, very solid. Very little steering in pitch and yaw. Now passing 9 minutes. 9 minutes and altitude now 103 nautical miles. Downrange distance 1,240 nautical miles and velocity 15,994 miles per hour. Less than 1 minute remains until SECO 1. Continuing to look good. Altitude now 103.5 nautical miles. Downrange distance 1,365 nautical miles. Velocity 16,518 miles per hour. Chamber pressure beginning to drop now in the second stage as we're about 15 seconds or so from SECO. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 10 seconds. Standing by for SECO. And we have SECO. All its system pressure has decreased. And we've had shutdown of the command receiver decoders expected. That we expect to be losing signal from Antigua very shortly as the vehicle will be going over the horizon. At 11 minutes, 37 seconds into the flight, altitude 104.8 nautical miles, downrange distance 1,857 nautical miles, velocity 16,947 miles per hour. This is Delta Flight Commentary at 12 minutes 5 seconds into the flight. We've just lost acquisition of signal from the Antigua ground station as expected. We expect to reacquire the vehicle from Dongarra, Australia tracking station in about 39 and a half minutes. So at 12 minutes, 24 seconds into the flight, this is Delta Flight Commentary. We'll pick up with the commentary a few minutes before we expect to reacquire the signal. Signal is expected to be reacquired about 51 minutes or so after launch, which would be about 38 minutes or so from now. This is Delta 2 Flight Commentary.
And this is Delta Launch Control in the Mission Directors Center, where the team is quite satisfied with the data that they have been watching and listening to during the ascent of the Delta II. We're now in a fairly quiescent phase as the second stage with Kepler and the third stage attached simply cruises along about 100 nautical miles above the Earth. The total duration of the cruise phase is about 43 minutes. And as we heard our telemetry manager, Steve Agid, say, our coverage from the Dongarra tracking station will come at about 51 minutes into the flight. And shortly after that, about 4.5 minutes later, the Tennant Creek tracking station in Australia will acquire. We'll get most of the second stage restart data from Dongarra, and then the third stage ignition and spacecraft separation will come through Tennant Creek. Tennant Creek is a station in the Australian outback, absolutely out in the middle of nowhere, but absolutely critically located for the events that we need to see on the Delta third stage and for spacecraft separation tonight. In just a moment, we'll be going into our launch replays of our liftoff of the Delta II with Kepler. At 14 minutes, 45 seconds into the flight of Kepler on the Delta II, this is Delta Launch Control.
Die US-Weltraumbehörde NASA hat eine Rakete ins All geschickt. An Bord ist ein neues Weltraumteleskop. Damit soll in den Tiefen des Alls nach Planeten gesucht werden, auf denen Voraussetzungen für Leben herrschen könnten. Das neue Teleskop heißt Kepler, benannt nach dem deutschen Astronomen Johannes Kepler.
Gibt es da draußen noch andere Planeten, auf denen Leben möglich wäre, so wie unseres? Die NASA lässt jetzt nachschauen. Sie hat das Teleskop Kepler ins All geschossen. Es ist benannt nach dem deutschen Astronomen Johannes Kepler. Es soll ferne Sonnensysteme nach einer zweiten Erde absuchen. Kepler kann zwar nur einen Bruchteil der vermutlich 100 Milliarden Sterne erreichen, aber vielleicht hat die NASA ja Glück.
Aufbruch zur Planetenjagd. Eine unbemannte Rakete startet in Florida. Sie schießt das Teleskop Kepler ins All. Eine ehrgeizige Mission, die neue Welten entdecken soll. Die Kepler-Sonde trägt die stärkste Digitalkamera, die jemals ins Weltall befördert wurde. Kleinste Veränderungen in der Helligkeit der Sterne wird sie mit ihren 95 Megapixeln festhalten. Die Größe und Beschaffenheit von Planeten kann so bestimmt werden. 3,5 Jahre lang beobachtet Kepler die Planeten der Milchstraße. Gibt es eine zweite Erde? Mit der Kepler-Mission wollen wir die Frage beantworten, wie viele Planeten da draußen, wie die Erde beschaffen sind, wie viele bewohnbar sind. Alle 350 Planeten, die Wissenschaftler bisher außerhalb unseres Sonnensystems entdeckt haben, sind zu heiß oder zu kalt, um Leben hervorzubringen. Das heißt aber gar nichts, glauben Astronomen. Wir wissen nur zu wenig und das soll mit Kepler anders werden. Wahrscheinlich gibt es sogar eine Menge Leben im Sternensystem. E.T. werden wir nicht finden, aber vielleicht E.T.s zu Hause. Die NASA freut sich über den erfolgreichen Beginn der Planetenjagd. Kepler ist auf Beobachtungsposten. Die Mission kann die Fantasie beflügeln, auch wenn die Chance, Außerirdische zu entdecken, eher klein ist.
Aber wenn E.T.s zu Hause gefunden ist, dann berichten wir auf jeden Fall wieder.
Wir haben das Weltraumteleskop Kepler mit einer Rakete ins All geschickt, um nach erdähnlichen, möglicherweise bewohnbaren Planeten zu suchen. Die Sonde ist mit einer 95-Megapixel-Kamera ausgestattet. 3 bis 3,5 Jahre soll sie arbeiten. Wissenschaftler schätzen, dass Kepler mehrere hundert neue Planeten finden wird.
NASA is conducting its most extensive mission to find planets in our galaxy which could harbour life. The Kepler telescope will orbit the Sun and observe more than 100,000 stars in the Milky Way in the hope of finding Earth-like planets. Our science correspondent Christine McGurty reports.
Engine start 1-0 and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Heading into space to search for planets like our own. NASA's described this mission as historic. It's the start of a 3-year survey of distant stars. The big question, are we alone in the universe, or are there dozens of other planets out there that could harbour life? The robotic spacecraft carries just one key instrument, a sophisticated telescope. While orbiting the Sun, it'll study more than 100,000 stars. If their light gets dimmer, that could be evidence of an orbiting planet passing by and blocking the light. Many experts are convinced there must be Earth-like planets out there somewhere.
We've seen over 340 planets outside our own solar system, but all of those really are much larger than Earth. Only one is kind of about double the size of Earth. But this is the first time that we will be able to actually detect something which could be the size of the Earth at the right distance from its closest star. So it's a real first in that respect.
The spacecraft is unique, equipped with the largest camera ever launched into space. NASA hopes it'll find planets in the so-called Goldilocks zone. Neither too hot nor too cold, but just the right temperature for water to exist and life to evolve. Christine McGurty, BBC News.